Welcome to lesson number 6. Today we're going to be looking at the laws of logarithms, and specifically we're going to be investigating the product law and the quotient law. So first thing we're going to do is evaluate the following, and I'm just going to plug this into my calculator and show you how we can evaluate this using our change of base identity. Now these two you might also just be able to do in your head if you're thinking about what exponent is 2 raised to give you 16, and the exponent that 2 is raised to give you 8. You would have 4 plus 3, and this is equal to 7. But I'm also going to plug this into the calculator to show you how you would solve a question like this. So change in base identity, remember we're going to turn this into log 16, and I'll show you on paper first. Log 16 divided by log 2. So log 16 divided by log 2 is equal to 4. And we would do the same thing with log 2 of 8, where I would have log 8 divided by log 2. So 4 plus 3 would give us 7. Now here, we have log 2 of 16 times 8. And so if you look at how this compares to the above example, we're multiplying now because the bases of our logs are the same. We're going to be multiplying these arguments. So 16 times 8 is 128. And so what we're actually solving is log 2 of 128. And if we think about this in terms of exponents, if I had an exponent of or a base of 2 rather, then what exponent would give me this answer of 128? Well, the answer there is 7 as well, but we can also use my change in base identity, which is what we did for this first one, in order to solve this. And so we would plug this into our calculator now, and I would go log 128 divided by log 2 gives me 7. So this is the same thing as this. And if we do the same thing for b here, so log 3 of 27, so if we were to think about this as a power with a base of 3 to the power of 3 is equal to 27, so log 3 of 27 is equal to 3, and log 3 of 3, remember, if the base and the argument are the same, then that's equal to 1. And that would equal 4. And we could also just plug this into our calculator using the change in base identity, where I have log 27 divided by log 3. We get 3, and then we could we go log 3 of 3, or log 3 divided by log 3, obviously that's going to be 1. And so we would have 3 plus 1 is equal to 4. Now likewise, just like we did over here, log 3 of 27 times 3 is 81, and 3 to the power of 4 would equal 81, so this answer is also going to be 4. And of course we can use our change in base identity here. So log 81 divided by log 3, and we get 4. Now if we compare these answers, so A to B, and not A to B, but the answers from 1 and 2A and 1 and 2B, these answers are the same. So 1 and 2 have the same answers. So this is investigating the product law, and so what I did was if we're adding logarithms that have the same base, so here we had a base of 2, we can multiply the arguments together instead of adding, using a change in base identity for 2 different logs, and so this ends up being a lot faster. Now we're going to look at the quotient law, and we want to do the same thing we did above, but notice how we're subtracting our logs now. So we want to evaluate the following. So log 2 of 16, we already know that log 2 of 16 is equal to 4 because that's what we had solved above. And log 2 of 8 we know is equal to 3, but now we're subtracting these two things, these two values. So we have 4 subtract 3, and this is equal to 1. Now if I have log 2 of 16 divided by 8, we can simplify this to log 2, 16 divided by 8 is also 2, and we know that this would also equal 1. Log 2 of 2, where the base and the argument are the same, this is equal to 1. Now, log 3 of 27 minus log 3 of 3, again, we already solved this. Log 3 of 27 is equal to 3. Now we're subtracting log 3 of 3, which is equal to 1, so this is equal to 2. And log 3 of 27 divided by 3, we can simplify log 3, 27 divided by 3 is 9. And what exponent would I raise this base to if it was an exponent? And that would be 2. Now, if we do the same thing we did above and compare the same answers, 1 and 2 have the same answer. Now these laws of logarithms, the product and the quotient laws, these can be summarized as follows. So if I have log a, where my base is a, and I take my arguments m times n, this is the same thing as saying log a of m, so this argument, plus log a of n, so this argument here. This is known as the product law. And so another thing you need to notice is if you are adding two logs together and they have the same base, then we would use the product law, and we could simplify it into something like this. Now, the quotient law, if I have two logs, so log a of m and log a of n that I'm subtracting, and the bases are the same, then all I need to do is I can divide my arguments. So m divided by n, and using the log a. This is known as the quotient law. So here we're going to evaluate the following using either the product law or the quotient law. So let's tackle this first one here. Log 2 of 12 subtract log 2 of 3. Now if I'm subtracting, then I need to use the quotient law. So log 2 of 12 minus log 2 of 3 is the same thing as log 2 of 12 divided by 3. And so this we could express as log 2 of 4. Now log 2 of 4, now this is something that if you want, you can take a longer approach to, and you can say, okay, well, log 2 of 4 is equal to v, and then you could express in exponential form, where you'd say, okay, well, 2 to the power of v is equal to 4, and then we would get v is equal to 2. Now let's look at this next example. I have log 6 of 9 plus log 6 of 8 minus log 6 of 2. Now, here, we're just going to be solving from left to right. So I'm going to start with log 6 of 9 plus log 6 of 8. And if I'm adding two logs together, then I'm going to be using the product law. So this is going to become log 6 of 9 times 8, and then we're going to subtract log 6 of 2. Now we can simplify this as log 6 of 72 minus log 6 of 2. So now I have 72, so log 6 of 72 minus log 6 of 2. Now we can use the quotient law to simplify. And so using the quotient law, this is going to be log 6 of 72 divided by 2, which is log 6 of 36. And this also is going to have a value of 2. Oops, sorry, I completely cut that off there. Sorry, let me just step through that again. So log 6 of 72 minus log 6 of 2, we use the quotient law for. And that gave us log 6 of 72 divided by 2, because I divided my arguments, which gives me log 6 of 36. And when we simplify this, we get 2. So 6 raised to what exponent would give you 36? Well, 6 squared would give you 36. And so our value for this log was 2. Next, we're going to look at class example number 2, where we're going to use the laws of logarithms to write log x of 10 plus log x of 75 minus log x of 2 plus log x of 3. And we want to write it as a single logarithm. Now, what we're going to do is we're going to start, again, left to right, but this is in brackets, and so we're going to treat this as one log, and we're going to treat this as one log. And so going left from right, we're going to have log x of 10 plus log x 75, which means that we're going to use the product law here. So this is 10 times 75. And we're going to be subtracting later log, so 2 times 3, also the product law if we're adding those together. But since we're going to be subtracting 2 logs, we're also, and I forgot my x there, we're also going to be using our quotient law at the very end. And so this is going to give us log x of 750 minus log x of 6. Now that we have our simplified logs, we can simplify them once again using our quotient law. So using our quotient law, this is going to become log x of 750 divided by 6. And so log 750 divided by 6, this is going to be log x of 125. 750 divided by 6 is 125. Now part B here, and this is the single logarithm that we're looking for. Now with part B, we want to evaluate this answer in A if x is equal to 5. So log 5 of 125. So what I did here was I substituted my value of x with 5, since x is equal to 5, is equal to, well, 5 to the power of what would equal 125? The answer here is 3. Now with class example number 3, we want to use the laws of logarithm to write log b of 2 plus log b of 3 minus log b of 6 minus log b of 8 as a single logarithm. Now, if you notice in your example, there's no brackets in this example. Now, if we were to insert brackets, kind of like we did with the above example, or like the above example also had brackets with it to begin with, what you'll find is you'll end up with something like this. And simplifying it into log b of 2 plus log b of 3, and then subtracting log b of 6 minus log b of 8, you'll get, this is how you would start the question. But there's 2 ways to do questions like this that don't have brackets. One way is to just solve left from right, or left to right. And then at the very end, you would end up with your simplified logarithm. Now the other way is to just be careful where you're inserting your brackets. And so this is where you want to insert them, but where we should actually insert them is right here. And so if I rewrite this, I would take care of this first statement, and this would be log b of 2 plus log b of 3 in one set of brackets. But if I insert the bracket here instead, then I would have to divide my negative sign or my subtraction signs out, and that would leave me with minus and then 2 positives, log b of 6 plus log b of 8. So that's one way that we could solve this problem, and then we could simplify. Now, the other way that we could go about solving this is without any brackets and just solving left to right. And so that's what I'm going to do here. And so this here is not how we would start this question. So just be careful with these types. Now, if we just solve left to right, then I am going to start with this log b2 plus log b of 3. And here I would be using my product law. So this would become log b of 2 times 3, which is log b of 6. And then if I continue solving left to right, ignoring all the brackets that I inserted, now I would subtract log b of 6. Now when I subtract log b of 6, this is just going to leave me with log b of 1. Log b of 1, because if I'm subtracting, that's 6 divided by 6, which is 1. And the last thing I needed to do is subtract log b of 8. And this is where we're going to get our simplified expression, where I have log b of 1 divided by 8. And this would be our final solution to this problem. Now, if I were to evaluate a, if b is equal to 2, so substitute 2 into my expression here, log 2 of 1/8 is equal to negative 3. Now, with these types of questions, sometimes it is very useful to put it back into exponential form. And so if we were to put this back into exponential form, then remember that what we're saying is 2 to the, if we, let me start there. If I have log 2 of 1/8 is equal to v, then we're saying 2 to the v is equal to 1/8. And remember, we can express this as a base 2. And so this would be 2 to the power of v is equal to 2 to the negative 3, and then v would equal negative 3. So just remember, if you're getting stuck here at this point, then you can convert to exponential form and then solve for your value. Next, let's look at class example number 4. The expression log 2 of x plus log 2 of 2x minus log 2 of x squared minus log 2 of y is equivalent to a, b, c, or d. Next, let's look at this next example. Log 2 of x plus log 2 of 2x minus log 2 of x squared minus log 2 of y is equivalent to a, b, c, or d. Now, I'm going to use the method of inserting a set of brackets in the proper spot, kind of like I alluded to up here, but I'm going to see this example through using that method. So what I was saying there was, if we want to rewrite this expression and deal with two separate logs that are simplified, sometimes it's a lot easier. So here is where I would insert my brackets, and then I would have to distribute these subtraction signs outside of my brackets. And if I do that, then it leaves two positives, which I would then use my product law for. And so I'm going to rewrite the new statement here, which is going to be log 2 of x plus log 2 of 2x minus, and this is where I'm going to have my new brackets, positive log 2x squared plus log 2 of y. Now we can simplify using our product law, and then at the end using our quotient law. So here I'd have log 2 of x times 2x. So log 2 of x times 2x minus log of 2 x squared times y. Now if I simplify this, I'll be left with log of 2 and 2x squared, 2x times x gives me 2x squared, minus log 2 of x squared times y is going to give me x squared y. Now I have my quotient law because I'm subtracting. So I have log 2 of 2x squared divided by x squared minus, or x squared y. X squared y. Now here I have two factors, not terms. I have two factors that can cancel out. So here and here, x squared and my x squared terms can cancel out, which would leave me with log 2 of 2 divided by y. And if we kind of use a reverse quotient law, remember if we're dividing two of our arguments, then we could also express this as such. So log 2 of 2 minus log 2 of y, which, remember, log 2 of 2 is equal to 1, and log 2 of y would just be log 2 of y. So our answer is 1 minus log 2 of y, which is option D right here. Now last, let's look at determining the values of 3 log 2 of p minus 3 log 2 of q if p divided by q is equal to 8. Well, first of all, if we look at 3 log 2, so we're multiplying both of our logs by 3. And so again, if we use the right brackets and think about what common factors there are, we can simplify this. And so this is going to become 3 that I factor out of here times log 2 of p minus log 2 of q. Now I can simplify using my quotient law. This becomes 3 times log 2 of p divided by q. Need my double bracket there to close it off. And this is going to be equal to, and p of q, remember, is equal to 8. So this is 3 times log 2 of 8. Now remember, 2 to the power of what equals 8? Well, 2 to the power of 3 equals 8. So log 2 of 8 is equal to 3. That would be 3 times 3, which is equal to 9.